Alrighty, so we are going to do this last example for partial fractions. This is partial fractions part 8. This was a really long section. Oops. All of these problems took a while to do. So I think there's 9 examples in this section. Each one took about a video. So let's just get through this last one. So the idea is, the last thing we're going to look at is evaluating integrals of this type. We have the integral square root of x plus 4 divided by x. So this doesn't fit into any of our categories that we've seen so far. It's none of the substitutions, not u substitution, not trig substitution. It's not going to be integration by parts. And it doesn't look like a partial fractions right now, but with things with integrals that look like this, we're going to be able to write them in a way to make them partial fractions problems. So the first thing we're going to do to make this a partial fractions problem is we are going to we're going to do a u substitution. And in any problem where you have this square root that you are trying to get to turn into something else, as long as there's no other u substitution to make that makes the integral doable, then the u substitution we're going to do is u is equal to the square root of x plus 4 in this case. So whatever is the root that you have. So if you have like the fifth root of x plus 7, you would do that. Whatever the root is, that's what you're going to let u be. That means du is 1 over 2 square root of x plus 4 dx. So I've just taken the derivative. If you don't see how that works, check it out. It's just power rule with just a little bit of chain rule there. Okay, so that tells us then that dx is 2 square root of x plus 4 du. So I'm going to rewrite this integral. The square root of x plus 4 is now u. I have an x down here. I'm going to replace dx with 2 square root of x plus 4 dx, or sorry, du. And now you can see, I don't want x's at this point. So what can we do about that? So if you look at the x inside the square root of x plus 4, we can take care of that. So that square root of x plus 4 is just my u. So this is then going to be equal to, I'm going to pull the 2 out of the integral, 2 square root of u divided by x, and then the square root of x plus 4 is just another u. So this becomes a u squared. So u times u. I have a du then. And now the problem is I still have this x in the denominator. So what can we do about that? Well, so anytime we do a u substitution, and if we're left with factors of x left over, we can use the u substitution that we chose and try and solve that for x. So I'm going to do that here. And as long as it's invertible, we should be able to. That's going to tell me u squared is equal to x plus 4. So x is equal to u squared minus 4. So then this is equal to 2 times the integral, u squared, and now x is u squared minus 4 du. And now if you're looking at this looks like something we might be able to use partial fractions on eventually. But the problem is, if you look at the power of the numerator, power of the denominator, they're equal here. So I need the power of the numerator to be less than the power of the denominator. So if you want, you can use polynomial long division. I'm going to use a trick here that makes it easier though. So when you have something that looks like this, again, polynomial long division probably isn't too bad. But I'm kind of lazy with math. What I'm going to do is I'm going to take the top, u squared, going to subtract 4 and add 4. So I've done nothing to change the top. The reason I do that is because if I look at this term here, this u squared minus 4, that's the exact same thing as the denominator. So I'm going to split up this fraction into u squared minus 4 over u squared minus 4 plus 4 over u squared minus 4. This is all du. That first term is just 1. Plus 4 divided by u squared minus 4. And you'll get the same thing if you do the polynomial long division. I just think, this is a little easier. If you can catch things like that, it makes life a lot easier. Okay, so that first integral isn't too bad. So this is 2 times the integral du plus the integral 4 divided by u squared minus 4 du. Okay, so first one again is just u. The second one, I'm going to have to do partial fractions on. So this factors as u plus 2, u minus 2. Okay, so we're going to have to do, so we know 1 over u plus 2, u minus 2. It's going to look something like a over u plus 2 for my partial fractions plus b over u minus 2. And now we're just going to go through and do the partial fractions. I'm going to get 1 over u plus 2 is equal to a times u minus 2 plus b times u plus 2, just making a common denominator here, which is, sorry, this is 1 over u plus 2, u minus 2 over here. Now the common denominator on the right-hand side is u plus 2, u minus 2. The denominators cancel on both sides. I can multiply them over and they cancel. So I get 1 is equal to, and go ahead and expand everything, au minus 2a plus bu plus 2b. So I have 1 is equal to, factor out the u, trying to make a polynomial. And I get u times a plus b. And then minus 2a plus 2b. So now if I equate coefficients on the left and right-hand side, so the coefficient on u on the left-hand side, I don't have a u, so the coefficient of u is 0 on the left-hand side. Coefficient of u on the right-hand side is a plus b. The constant term on the left-hand side is 1. Constant term on the right-hand side is 2b minus 2a. And now I can solve these. So this tells me a is equal to negative b. And the second equation, when you, so first one gives me a is equal to negative b. I can take that and put it into the second equation. I'm going to get 1 is equal to 2b plus 2b. Okay, so that tells me then that b is equal to 1/4, which then implies a is equal to negative 1/4. So let me double check my work there real quick. So it looks okay. Yeah, looks okay. So I'm going to use this then. I'm going to put this back into, up here. So I'm going to then have 1 over u plus 2, u minus 2 is equal to negative 1 over 4, u plus 2 plus 1 over 4, u minus 2. Let me make sure that was the form I had there. So a over u plus 2, yeah. So then my integral now, so if I go back up and look at the integral I was doing here. So, sorry, getting rid of the highlighting, brought me back down. So I'm just going to split up that fraction using the partial fractions form I just found. So my integral then is 2 times the quantity of u. I think it's a plus up here. Yeah, plus 4. So 4 times, and I have the integral negative 1 over 4 u plus 2 du plus the integral 1 over 4 u minus 2 du. So just splitting that up using partial fractions there. All right, so this is going to be 2 times u. I can factor the 4 out from each of those integrals down there on the right, or the 2 integrals I have left, and that cancels with the 4 here. So I'll go ahead and mark that. That cancels with those. So I can factor those out. This is u plus, so actually u, this is a minus because the first integral has a negative sign. So u minus the integral 1 over u plus 2 du plus the integral 1 over u minus 2 to u. These are logarithms now. So this is 2 u minus ln of the absolute value of u plus 2 plus ln the absolute value of u minus 2 plus a constant. Okay. So last thing to do is just put everything in terms of x now. So u was the square root of x plus 2, I think. X plus 4. So u was the square root of x plus 4. So I'm just going to replace all my u's with the square roots of x plus 4. And this will be my answer. I clean up that last one a little. Let me clean up that entire thing. Hang on. So yeah, so that's one too many bars there. Something was going wrong. So ln of square root of x plus 4 plus 2 plus ln of square root of x plus 4 minus 2 plus my constant. And then just, I'm going to distribute the 2. And that'll be it. That'll be my answer. All right, so again, there's some partial fractions in here, but you know, the big overarching point of this problem, the reason we did it is because we started with something that, you know, didn't exactly meet the form of partial fractions that we're used to, but you know, using this u substitution, u is equal to square root of x plus 4, we're able to turn into something that we could use partial fractions on and then integrate it. You're going to have to do that a couple times in the homework, but again, the u substitution you're going to do is u is equal to the square root of whatever, the fifth root of whatever. So whatever's inside the square root, you can try that out first. Whatever the square root is, you're going to try that out first. So I think, yes, that's going to be the last example for this one. I'll post this, and then if you have any questions, just feel free to reach out. We'll get it settled up. I'll post all these notes online so you can look through them as we go through, because I know it's hard to see me scrolling through this. But yeah, so stop the recording here.